So we can do like 5-6 kilo a day just for making express. But the most important part of the machine is we first is the shredder. So all these normally detergent bottles, everything that we used to just throw away. Now we just put it in and get it shredded and make it to like small pieces. And these small pieces now can go here. This is the extruder. So the extruder basically hits the plastic, make it melt, and it can make a lot of other stuff.
So it starts with a pool, like a pool of a string of things. So this is freehand made without any mold. So this is with mold.
And we also have something like injection molding. So all the molten plastic can go through, extrude, and we can make different shapes. For example, like make the turtles. Okay. So one of the things that we do is because we want to make the renewable energy, like especially the hydro turbine, accessible. One of the biggest problem is cost. So our idea is to how to reduce the cost to make these turbines. So we have been trying to do some R&D. We have built this smelted the aluminium, make it into a mold, and we extrude the molten plastic. And actually we can get this.
Oh, you can make. Oh, I see. So this is all made.
Yeah. So this is the finished product cup. And we can mount this into the hub, and you can, voila, we have a turbine. So all those different things. We hope that later, when we can get our process much more improved, we can even make this casing, body making from this. So we also make aluminium. We smelted this aluminium from beer, all the beer, and make it into this hub.
You made that here.
Yeah, this is
You make mini hydro with beer cans.
Design.
Okay.
So we make all this. So in the process of trying to achieve this accessibility, affordable energy, because we want to stop importing this system from outside. So now we have different type of turbine. So we can see our capability is to make from a small 1 kilowatt into like 40 kilowatt. We can also make different type of turbine. We have pelted, we have turbo, and also cross flow turbine. So all depends on the sites. So that's why in the UKPEC project, we did a lot of the feasibility study to really understand whether they have the right kind of flow. Secondly, with the right head, the height, and by having that data, then we know which type of turbine is actually very more suitable for that. So that's what we want to make sure that we have this capability locally. And the rest of it goes to the spinning, machining, building, and then that is the finished product. That is sitting on the top of the
That's what the final thing looks like.
Yeah. So Bill and Dan, can you explain this?
And that's being used to not only test the turbine and the generator setup, but also the control effect of the turbine.
And is this actually inside? How it would be in
It is, but it doesn't generate as much power as what would be on site, but it gives them an idea of how it is. So this is a real size generation, a real size turbine.
Okay.
So one of Dan's biggest role is actually transfer of his idea and expertise to our local expert, our local guys, in order for them
later on can replicate this system, and hopefully we can continue to produce the controller.
Do you have an engineering background with this?
That helps us all the of that. So usually we buy from overseas, like Indonesia. So that's for this so now we can make it on our own.
You make all of this here.
Yeah.
Everything. Even to the small soldier like this. To the
Yeah. It really reduces the cost, like around 50%.
And this is the control panel for the
how much less? Yeah, let's